Welcome to today's tutorial. If today is your first time of joining Great Academy, please like and subscribe and as well share this class so that it will get to people that need it most. So in today's class, we shall be treating mole calculations. So in example 1, the question reads, given the equation for the reaction between calcium trioxocarbonate 4 and hydrogen trioxonitrate 5. Full stop. Before I continue reading, you have to understand that many examiners will not give you the chemical formula of these compounds. They will give it to you in words. You will be the one to assemble them together and write them together and as well solve it. So it's very much important that you keep following this channel. Always like and subscribe so that you will get my next post. I will always treat these issues one by one. Then let me continue. What mass of calcium trioxocarbonate 4 is needed? I will read that again. What mass? They did not say what mole. They said what mass of calcium trioxocarbonate 4 is needed to give 0.25 mole of calcium trioxonitrate 5. You see, they did not give you the formula of calcium trioxocarbonate 4. Okay, it's given. But the formula for calcium trioxonitrate 5 is not given. So it's through your chemical equation that you are going to, get that. And thank God I've given it to you already. So the first thing to do is to write solution. This is a problem and you want to proffer solution. As a chemistry student, your main objective is to always proffer solution to problems relating to chemistry. Understood? I forgot to tell you, this is going to be an interactive class. So it is me and you in a classroom learning from me. So make sure you have your paper and pen and make sure you listen very attentively. Now the first thing to do is to write out the equation. So you have HNO3, then CaCO3 to give you Ca bracket NO3, close the bracket, and you have subscript of 2, then H2O and CO2. I've already named the first and the second compound, as well as the third compound, which is calcium trioxonitrate 5. And the next one is a very popular one, even those in arts and commercial arts classes. They know that the chemical formula of water is H2O. Then the next one is what we breathe out every day, which is CO2, carbon 4 oxide or carbon dioxide. So in this equation or this reaction between HNO3 and CaCO3 produced CaNO3 and water plus carbon 4 oxide. So in this reaction now, carbon 4 oxide is given out, right? Now, for you to balance this equation, you have to note the atoms and the number of those atoms, in each of the elements. The first compound has 3 elements, which is hydrogen, nitrogen, and oxygen. Second one, calcium, carbon, and oxygen. So basically, in this whole reaction, we have hydrogen, we have nitrogen, we have oxygen, we have calcium and carbon as the elements that make up the whole formulas or the whole compound in this equation. If you look at the first one, let's say I haven't balanced this before now, so let me balance them again. If you look at the first compound, which is HNO3, you find out that the first H here or the H here is actually mono, like it has only about one atom, that is one hydrogen atom. But if you look at the product side, you have 2 hydrogen atoms. So yes, that is true. Now for you to balance the hydrogen, to be equal, both the left side and the right side, you have to add 2 here. If you add 2 here, you will now see that you have 2 hydrogen atoms here and 2 hydrogen atoms here at the right hand side and the product side. They are equal. Now these two you introduced here is not only for hydrogen this time around, but also for nitrogen and oxygen. So you have 2 atoms here of hydrogen, 2 atoms of hydrogen here. For nitrogen, same 2 multiply 1 atom of nitrogen to give you 2 atoms of nitrogen. And in this place, that is the product side, which is in this CaNO3, then you have 2. These 2 outside the bracket is governing everything inside the bracket. The 2 outside the bracket is governing everything inside the bracket. So you have 2 times 1 nitrogen here. That will give you 2 nitrogen atoms. And here we also have 2 nitrogen atoms. So we've balanced that one. Same thing applicable to oxygen. You have 3 as the subscript of oxygen here, and multiply by these 2, you have 6. And 6 plus the 3, the oxygen in, calcium triazocarbonate 4, that will give you 9, total of 9 oxygen atoms. So you have to also balance it, at the product side. So you have 2 times, that is 6 oxygen here, plus 1, 7, plus 2, that is 9. The next one is calcium, 1 calcium, 1 calcium, so nothing changed. Then next one is carbon, 1 carbon, 1 carbon, nothing changed at all. Is that okay? Please, it's very much important to understand balancing of chemical equations, because they are very, very much important. If you don't understand, please make sure to subscribe so that you will understand. Now let's solve this equation. We've gotten, let's solve this problem. We've realized that the number of moles of hydrogen triazonitrate 5, is 2 moles, and it combined with, or it needed 1 mole of calcium triazocarbonate 4 to produce 1 mole of calcium triazonitrate 5, 1 mole of water, and 1 mole of carbon 4 oxide. So if you followed me to this point, well done. And the next thing is to go back to the main question, which is what mass of calcium triazocarbonate 4 is needed to give 0.25 mole 0.25 mole of calcium trioxonitrate 5. So if you look here now, you will find out that we are dealing with calcium triazocarbonate 4 and calcium trioxonitrate 5. And the main problem here is to find a mass of CaCO3. So let's deal with this demon. 1 mole of CaCO3, from the reactant side gives 1 mole of Ca bracket NO3, from the product side. Now from the question given to us, you are given that 0.25 mole of this was produced, but we don't know the mass that produced that. So let's say that let the mole of calcium triazocarbonate 4 that we produce 0.25 mole of calcium triazonitrate 5 be X. So let's say X mole of CaCO3 be 0.25, that is 0.25 mole of Ca bracket NO32. So the next thing to do here is to cross multiply. Now you have X mole to be equals to 0.25 mole. This time around is not for CaNO3 again. So NO3 close the bracket 2. It's now for CaCO3. You see? From well-balanced chemical equation to getting the actual number of moles of calcium triazocarbonate 4 that will produce 0.25 moles of calcium triazonitrate 5. That's all right. And the question is, what mass of this calcium triisocarbonate 4 that will be needed to produce that 0.25 mole of calcium triisonitrate 5? So you have to calculate the molar mass of CaCO3. So in brackets, calcium is 40. That's the atomic mass of calcium is 40. Then carbon is 12 and oxygen is 16. And to calculate for the molar mass of a compound, you have to add all the individual atomic masses of the elements that make up the compound. And if you look at the compound, we have three principal elements that make up the compound: calcium, carbon, and oxygen. Please always try to take note of the subscripts. So calcium is 40 and carbon is 12. Then our O, which is oxygen, is 16 multiplied by 3. And that will give us 100 grams. I'll give us 100 grams of CaCO3. Now to get the mass of CaCO3 that would produce 0.25 moles of calcium trioxonitrate 5, it will be 100 multiplied by 0.25. This is the mole that you've got. That's mole of CaCO3. And that will give us 25 grams of CaCO3. Is that okay? So get the pattern right now. We first of all balanced the equation. That was the first thing we did. We balanced the equation. And through our balancing, we got that 1 mole of calcium triisocarbonate 4 produce 1 mole of calcium triisonitrate 5. But we don't know the actual mole of calcium triisocarbonate 4 that will produce 0.25 mole of calcium triisonitrate 5. Yes, that is the pattern I love using, to deal with mole concept. You can still use mass to mass calculation and solve it and still get your answer. But this way is very much self-explanatory. Now, after solving, we got that the number of moles of calcium triisocarbonate 4 that will produce 0.25 mole of calcium trioxonitrate 5 is 0.25 mole. And we are not stopping here. We are not stopping here because it's not actually what we are told to calculate. This particular mole here is for us to be able to get the actual mass of calcium triisocarbonate 4 that will produce 0.25 mole of calcium triisonitrate 5. After solving and you got this 0.25, the next thing to do is to calculate the molar mass of calcium triisocarbonate 4. And I want you to know this from today, that the atomic mass of calcium is 40, carbon is 12, and oxygen is 16. And for you to calculate the molar mass of a compound, add all the atomic masses of the element that make up the compound. And if you look at this calcium triisocarbonate 4, we have 3 elements: calcium, carbon, and oxygen. Okay? So calcium is 40. This is 40. Carbon is 12 and oxygen is 16 multiplied by the 3. This 3. That is a subscript of oxygen. And everything will give you 100. 40 plus 12 is 52. And 16 by 3 is 48. And 48 plus 52 is 100. Once you reach here, it means you are about to, solve the problem very well. And the next thing to do is to multiply your molar mass by the mole that you got. The molar mass is 100 and the mole is 0.25. And when you multiply this, you have 25 grams of calcium triisocarbonate 4 that will be needed to produce 0.25 moles of calcium trioxonitrate 5. That is all about this particular problem. And I know you understand it very well. There is nothing difficult here. The first thing is to balance. Second thing is to get the mole if you are solving with mole. And the next thing is to multiply by the molar mass. And to get the molar mass, you add the individual atomic masses of the element that make up the compound. Is that okay? Please, if you don't understand, go back and rewatch the video from the beginning. But I believe that you understand very well. So example 2 says, what mass of sodium oxide, Na2O, that is the chemical formula of sodium oxide, could be obtained by burning 11.5 grams of sodium in air. So burning of sodium in air will produce Na2O. So the first thing to do is to react. You have sodium plus oxygen to give you Na2O. And they said what mass of sodium oxide, which is this Na2O, could be obtained by burning 11.5 grams of sodium. So we are working with sodium and Na2O. But the second thing I say you should do after balance, after your equation is balancing. And to balance, you have to look at both sides, the reactant and the product sides. Sodium at the right hand side is just one atom, but here is two atoms. So you have to add 2 here to make it 2 atoms, 2 atoms. Then that of oxygen is 2, here is 1. So you see, if you add 2 here now to make oxygen at the product side 2, you've actually changed the value of sodium. So you will clean the previous one you wrote, which is this 2. You will clean it and add 4 here. That is 4 atoms of sodium, and 2 times 2, 4 atoms of sodium. And for oxygen, you have 2 atoms here, and here you have 2 atoms. So you've done justice to that. You have sodium is 23 times 2 plus 16. And 23 times 2 is 46 plus 16. That should be 62 grams. So the reacting mass of sodium here is 4. So 4 by 23 of Na produced 2 by 62 of Na2O. Is that okay? I'm solving using the reacting masses. If you solve with 23 alone and 62 alone, you are going to fail it. You understand me now? That's all right. So let's continue. But from the question they said, what mass of sodium oxide could be obtained by burning 11.5 grams? So we don't know the mass of sodium oxide that will be obtained by burning 11.5 grams. So we are going to call that mass that we don't know X. So 11 point, oh, that's very bad. 11, oh God, what's wrong with me and H? 11.5 grams of the same sodium will now produce X gram of Na2O. Is that okay? All right, so 4 by 23 will give you, it will give you 92 grams of sodium, and 2 times 62 will give you 124 grams of sodium oxide. Now you have 11.5 grams of sodium to give you X grams of sodium oxide. Once you reach here, you are very close to, getting the solution. So the next thing is to cross multiply. Very much careful here. So 92 times X, that will give you 92X. Then 11.5 times 124. Do you understand that? I just cross and multiplied. And if you reach here, welcome. Now the next thing to do is to divide both sides by the coefficients of X, which is 92. Do you understand? You've multiplied and you got 92 and 124. The next thing you did was to cross multiply. And the next thing to do is to divide both sides by the coefficients of x, which is 92. So after your division, you will have 15.5 grams. Is that okay? Therefore, that mass, the mass of Na2O obtained is 15.5 grams. All right. So let me clean this. All right. So that is how to solve it. All right. Let's solve the third question. Calculate the mass in grams of copper that will be deposited by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6. I'll take that again. Calculate the mass in grams of copper that will be deposited by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6. So the first thing to do is to react. That is your equation of reaction plus copper tetraoxosulfate 6 is CuSO4, and that will give you ZnSO4 plus Cu. Is that okay? So from here, there is nothing to balance because it's already balanced. So you have 1 mole, you have 1 mole, you have 1 mole, and you have 1 mole. Now go back to the question. The question says, what or calculate the mass in grams of copper that will be deposited by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6. So we are to calculate the mass of copper that will be deposited. Do you understand? Mass of copper that will be deposited by dissolving 6.5 grams. All right. So what to do here is, right, so the next thing to do is, to actually use what's given to you in the question to continue dissolving. So 6.5 grams of zinc will now give us x grams of copper. From the atomic masses, 65 grams of zinc will give you 63.5 grams of copper. But we don't know the mass of copper that will be produced from 6.4 grams of zinc. That is why we called that mass X. So whatever thing we get as our X, we become that mass that will be produced by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6. Is that okay? All right. Now, next thing to do is to cross multiply. You cross multiply. Once you cross multiply, you have that 65x, that's 65 times x will give you 65x. We now give you 6.5 multiplied by 63.5. Then the next thing is to divide both sides by the coefficients of x, which is 65. So this one will cancel out this, remaining what? X. 65, 6.5 multiplied by 63.5. That will give you 409. My own calculator said 409.5. We divide it by 65. So let's divide it. Divided by 65. And my own calculator gave me 6.5 grams of copper. 6.5 grams of copper. Remember, we said that let the mass of copper that will be deposited by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6bx. So in the end, we got that, or we realized that X, is equals to 6.5 grams of copper. So we now say, therefore, the mass of copper that will be deposited by dissolving 6 point, by dissolving 6.5 grams of zinc in copper tetraoxosulfate 6 is 6.5 grams of copper. Or you can just, 6.5. And that is your final answer. So these and more will come in the next tutorial. But I want to make sure you understand this very well. The first part is understanding the question. Second is having the equation of reaction. The third is balancing if there need be. Then the last one is to solve the calculation or the problem. And make sure that you follow them very well. Don't miss any step. And like I said, you can use mass to mass and solve this kind of problem, or you can use mole to mass or mass to mole, and you will still get the same answer. But the pattern I'm using is the most, let me say, the simplest one to use, and it's highly self-explanatory. In this way, if you have any problem or confusion, the comment section is always there for you, and I will be right there to help you explain better. See you in the next tutorial. Don't forget to like, share, and subscribe. Thank you.